Hi everyone. Today we're going to design non-inverting amplifier using LF353 op-amps. So what is so special in LF353? These are called BIFET amplifiers. Earlier actually in the examples, we talked about bipolar op-amps. And now today we are talking about BIFET op-amps. What is the difference between these two? Bipolar amplifiers are made of BJT transistors, bipolar junction transistors. BIFET amplifiers are made of using FETs in combination with BJTs. So this is called bipolar. Apart from this naming, what else is the difference? This is connected where, if you just remember my first class, this is connected at the gate and other intermediate stages of the op amps, right? So that means the IB current will be more here in case. If I use the BIFET, IB current is less. IB current is more here. Okay, these are the differences of it. And there are many other differences between the bipolar and BIFET about the resistance variations and all those things. So we'll just take the bias current at this moment. This is IB is what? Input bias current. Now, let us construct the non-inverting amplifier using the FETs. This is V0 and this is RF, and this is called R2, and this is called R1. What are we trying to do now? So we are going to deduce the formula for the non-inverting amplifier. Let us start with the assumption. In the previous example, we started with IB should be far less than I2. That means the current through this circuitry should be more as compared to the IB, because if you have money, then only you can able to lend money. This is IB. IB is taking from this particular, right, circuitry. So you need to have what is called as a more I2, or it simply say that I2 is 100 times than that of the IB. So if you go with this particular method, then what happens is that you will end up with the very high values of the RF and R2. So this high values of the resistors causes the high values of the resistance, and these high values of the biasing resistance can cause charge accumulation at the MOSFET inputs. Let us consider this is IB, and this is also IB. This is input bias current. Here the terminal is called V1. Here the terminal is called V2, and this is the input. If I write it, this input goes to MOSFET here. So this is made up of MOSFET. That's why it's called BIFET. Now what happens here is that although current is pretty less, because of the more resistors, biasing resistors, there is a charge accumulation at the input of this uh, at the gate terminals of the MOSFET. It takes a lot of time to discharge as well. So this causes the uncertainty in the biasing of the op-amp. Secondly, this causes the stray capacitance. If there is a stray capacitance, then it causes the oscillations of the op-amp. So now that's why, so we have to have it by thumb rule, we have to keep certain value which is less than 1 meg. Let us keep around 800K to 1 meg. So, but let us go with the 1 meg for simplicity, okay? So RF is equal to 1 meg. So I will write here 1 meg ohms. The closed loop gain ACL is nothing but equal to 1 plus it is RF divided by it is R1. It is RF divided by R1, which is nothing but equal to Not sorry, this is R2. ACL minus 1, or it is R2. You have to identify it is RF divided by ACL minus 1. What is R2 and what is RF? RF, we need not worry. It's 1 meg. What is ACL? In the previous, actually, we saw ACL examples. It could be 50 or it could be 60 or something like that. But I'm going to take around 61 just for the simple calculation purpose. 61 minus 1. So R2 is equal to, it is nothing but your 110 to the power of 6 divided by 60. Let's calculate it. So 1.66 into 10 to the power of minus 2 plus is equal to, or 1.66 into 10 to the power of 4, or it is 16.6 K ohms. So you can put it over here. It is 16.6 K. Now, hey, sorry. Now we have to find out R1. It's pretty easy. What is R1? It is nothing but equal to the parallel circuit. The resistance should be equal. Earlier also I told the resistance at the terminals should be equal. So R1 should be equal to RF parallel R2. What is RF parallel R2? R1 is equal to, what is RF? 1 meg parallel 16.6 K. Let us calculate R1. So when there is a very big value which is in parallel with this one, so this will approximately, the other value will be the lower value of the resistance. You know that 6K ohms. So this can be 16.6K ohms. Simple. So now we have completed the design of the non-inverting amplifier. If you like it, please do share this and also give a thumbs up. Thank you so much.